Oh, welcome back, everybody. This is the solution set for homework assignment 12.2. Let's begin. Let vector u equals 7, 5 components of 7 and -5. Find the component form and magnitude length of the vector 3u. 3u means 3 times 7 -5, which means just distribute, so it's 21 -15. So that's the first one. So we have 21 in here, -15 in there. Now we find the magnitude. So since it's a constant magnet that comes out in front, we just find the magnitude of u and triple it. So we have 7 squared plus -5 squared, 21, no, 49, I'm sorry, 25, which equals the square root of 74. Times 3. So the answer is 3 radical 74. That's the first one. Let the vector u equals the components 4, -2, and vector v, -1, -5. Find the component form and the magnitude of u plus v. All right. The component form of u plus v is 4, -2 plus -1, -5. So 4 minus 1 and -2 minus 5, which is equal to the components 3, -7. 3, -7. Now the magnitude of those, since we added those become 3 squared plus -7 squared, 9 plus 49 equals the radical of 58. All right, so those are the first two. It's pretty much component by component. Find the component form of the vector from point A to the origin. So A is at 5, 6, and the origin is at 0, 0. So look at the distance is 0 minus 5, and then 0 minus 6. So the components for that one, for those are -5, -6. This is coming from this is point A, this is point B, so it's always a difference between. Find the component form the unit vector obtained by rotating the vector 1, 0, 60 degrees counterclockwise. So the magnitude of this vector, 1 squared plus 0 squared is 1. So since it rotated counterclockwise, so we have cosine theta, sine theta. Since absolute magnitude is 1, we just really have cosine of 60 and sine of 60. Cosine of 60 is 1/2, and that means the sine 60 is radical 3/2. So the answer is D. Express the vector direction of P1, P2 in the form of the vector in component form. If P1 is the point 088 and P2 is 839. So what that's saying is P1, P2, it's always going to be the second minus the first. Y2 minus Y1J, C2 minus C1K. So 8 minus 0, I. 3 minus 8, J. 9 minus 8, K. So that equals 8 minus 0 is 8. 3 minus 8 is -5. 9 minus 8 is 1K, which is K. 1K. Question number 6. Same thing. So we have P1, P2, which is -3 minus -3, I. -4 minus 1, J. 1 minus 0, K. That becomes a plus. It's 0I minus 5J plus 1K. So it's 0, -5, 1. Express the vector 9J as a product of its length and direction. So it's just 9J. 9J comes from the vector 0I, 9J, 0K. So it's going to be 0. And since the magnitude is 9, we can factor that out. So it's 1 and 0. All right, so that's for 7. This is the next sheet. That was 7. No, wait, number 8. Find the points P1 and P2, given the values, in the direction P1, 2 and the midpoint of the segment. Okay. P1 to P2. So it's always the second minus the first. So it's 2 minus -3I. 1 minus 3J. 0 minus 1K. So that becomes a plus. So we have 5I minus 2J minus 1K. So 5 minus 2 minus 1. Now the midpoint is simply the average of each of those points. So add the exponents together, the x values, the y values, and z values. So it's -3 plus 2 over 2. The y's are 3 and 1, so it's 3 plus 1 over 2, and 1 plus 0. Negative 3 plus 2 is negative 1 over 2. 3 plus 1 is 4. 4 divided by 2 is 2. And then 1/2. So it's negative 1/2, 2, and 1/2. Okay. Suppose that A, B, and C are the corner points of the thin triangular plate of constant density shown here. Okay, find a vector from C to the midpoint M in vector form. So what we have to first do is find the midpoint between A and B. So the x values are 6 plus 4 over 2, 5 plus 1 over 2, 0 plus 0 over 2. So the midpoint is at 6 plus 4 is 10, divided by 2 is 5, 6 divided by 2 is 3, 0. So now we're looking for from C to M. Well, C is the point 1, 1, 3. So it's the M value minus 1i, 3 minus 1j, 0 minus 3k. Four I plus 2j minus 3k. Okay, yeah. So that's what was inside the points there. So find the vector from C to the point that lies 2/3 of the way between C and M in the stadium. So all we do here is we're looking for, let's call this vector V. So we're looking for the 2/3 of vector V. So it's 2/3 times 4i plus 2j minus 3k. So just distribute those. 2 times 4 is 8 over 3i. 2 times 2 is 4 over 3j. The 3's cancel, so it's just negative 2k. So it's 8 over 3, 4 over 3, minus 2. Find the coordinates of the point which the medians of A, B, C intersect. So we're looking for the point that's in the middle. So all that really means, we're looking for the midpoint of the midpoints. For A, B, and C. So let's take the values of the x values, 6, 4, and 1, divided by 3. 5, 1, and 1, divided by 3. 0, 0, 3, divided by 3. 11 over 3, 7 over 3, 3 over 3, which should just 1. So the answer is 11 over 3, 7 over 3, and 1. Right, that's all for that one. Good luck, everybody.